Check one. Right. Hello, everybody. Today, a special program is planned. That is, we finished off our Chem night. In Chem night, we mainly focused into the theory section. Right? Theory section, we revise, we memorize, put into the mind, and that is done in the Chem section. Chem night. We didn't touch any questions. So today, we are going to touch the questions. Electrochemistry was done in Chem night. No? So I already sent you all the past paper questions from electrochemistry. So some selected past paper question we are going to discuss today. Maybe with time, right? Maybe with time, we'll be continuing it tomorrow as well. Okay, that's the plan. Before we start, confirm me whether you can hear me properly. All duos are perfect. All good. Okay, no? Hurry. Without any further delay, we'll start because there's a lot work to be done today. I hope you all have finished. Now I gave you all 2 days. Last Tuesday I told about it. Last Tuesday I told about it. Tuesday night, no? So yesterday was their full day. Today almost full day. So 2 days. I hope you all did, right? I will be discussing the essay questions. Essay questions will be going in reverse, starting from 2021 O-level paper, question 15, 14, 13, 12, 11. That's the plan for today. We'll see with the time, right, how it goes. Without any further delay, we'll start. Unnalamai, from your end, I hope you all have done the question. Even if you are not done the question, now listen. Ne? Now listen. Right. Hmm. Right. Question 15, 2021 O-level paper. Roman 1, a blue-colored aqueous solution of the sulfate of metal copper on blue color aqueous solution of the sulfate of metal copper. What is the compound they are talking about? Blue color aqueous solution of the sulfate of metal copper. What's the sulfate of metal copper? And right, copper sulfate. Hari nilamai, copper sulfate is blue color. Was electrolyzed using carbon electrode. They are talking about electrolysis of aqueous copper sulfate. Can remember? Electrolysis of aqueous copper sulfate, our third electrolysis. In the short note, electrolysis third block. Question letter A. Write the half reaction taking place in cathode. Hari. We'll quickly revise on copper sulfate electrolysis. Dingala will revise. Now things should flow in your mind. Those who joined the chem night, now the things should flow in your mind. Onnalamai copper sulfate aqueous solution. Copper sulfate aqueous solution. Electrolysis. Electrolysis. What you do? Beaker is there. You fill the beaker with. Copper sulfate aqueous. Copper sulfate aqueous. Copper sulfate aqueous. Copper sulfate. Just after you write this, write the ions in the solution. Easy, no? Copper sulfate aqueous. Dingala, tell me the ions. Copper sulfate. From copper sulfate. What's the positive ion? What's the positive ion? If you can't type, at least shout and tell in your house. Then only things will go into your mind. Cu plus 2. Negative ion? Negative ion? SO4 minus 2. Is that all? No. It is in aqueous state. If it is in aqueous state, water will undergo ionization. From water's ionization, what's the positive ion? Open the mouth, tell louder. Now things should go into your mind. H plus on the right. What's the negative ion? What's the negative ion? Hydroxide. OH minus. Those are the ions. Electrolysis. What we do? What we do in electrolysis? We put the carbon electrode, connect it to a power supply. Can remember? Our second part we learned. Electrochemical cell is the first part. That is a cell, electrochemical cell. There we produce current, first part. Now second part. Here we send current, do a reaction. Can remember? Can remember? Second part. So you put the two rods. Usually what are the two rods we put? Things should come into mind. Usually what's the two rods we put? Carbon electrode. Is that the only electrode we can put? Carbon graphite. Is that the only electrode? Another one is there. What is the other one? What is the other one? Platinum. Platinum. Right. You connect it to an external power supply. Positive, negative. Electrode connected to the positive terminal is positive. Electrode connected to the negative terminal is negative. Now, can you all remember the shortcut I taught you in electrolysis? Positive ions go to the negative electrode. Negative ion go to the positive electrode. And can you all remember the word no? Yes, that is no. Negative ion undergoes oxidation. Now can you understand why those shortcuts I taught you? Very quickly, those things when it comes to the mind. Essay question that takes about 10 minutes. Usually essay question is 20 minutes. No? This is a part of the essay which takes about 10 minutes. You can solve it in 5 to 6 minutes. So that's why I taught you these things. No. Negative ion undergoes oxidation. Two negative ions are there. Sulfate and OH minus. Who will undergo oxidation? Who will undergo oxidation? And right. OH minus undergo oxidation. Positive ion undergoes reduction. Two positive ions are there. Out of them, who will undergo reduction? The one that is lower. And right. Copper 2 plus will undergo reduction. Basically, copper plus 2 will go to the negative terminal, undergo reduction. Hydroxide ion will go to the positive terminal, undergo oxidation. Can you remember? Tell me the reactions. Tell me the reactions. Oxidation. 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 Oxidation is oxidation of hydroxide ion. Can remember? We memorized? Open the mouth and tell. Open the mouth and tell. 4OH minus aqueous converts to 1 oxygen, that is in gas state, to water plus 4 electrons. That's the oxidation. Water is in liquid state. Reduction. Positive ion undergoes reduction. Copper plus 2 here undergoes reduction. Can remember the reduction of copper plus 2? Gaining electron. Copper plus 2 aqueous gains how many electron? 2 electron forms what? Copper. What happens to the color of the solution? What happens to the color of the solution? Decrease. Blue color intensity decreases. What gas evolves at anode? Oxygen gas. Gas bubbles are liberated. What is deposited at cathode? Copper. Now go to the question. Now all those who join the chem night with your consciousness should be able to answer this question. Or patta gala, you should be able to answer this question. Blue colored aqueous solution of copper sulfate, sulfate of the metal copper was electrolyzed using carbon electrode. Write the half reaction taking place at cathode. Cathode. At cathode, what's the half reaction taking place? Reduction. What is a reduction? What's a reduction? We wrote. Make a nilamai. Take 1 marks. Nothing 2 marks. Hurry. That is question number 15, right? 15 Roman 1A. 15 Roman 1A. Those who didn't do, before me do. Before me and finish. Reduction. Reduction is copper plus 2 aqueous. Gains 2 electron, forms copper. Next. B. What kind of color change occurs in the electrolytic solution during the above electrolysis? Everyone tell me. What will happen? What will happen? Blue color intensity decreases. Properly write it. Now you know the logic. No? Don't put the examiner into a situation where that fellow has to think. That fellow is just there to mark your paper. Teachers doesn't like to think. We like to just read your answers and then mark it. So don't give a situation where teacher has to think. So properly write. Blue color intensity of the solution decreases. Don't leave even a single point for the examiner to cut marks. Okay. So properly write. Blue color intensity. That's how you answer your questions. Some fellows are lazy. Blue decrease. Color decrease. Essay questions. Elaborate and nicely write the answer. But that doesn't mean you have to write an essay on it. Be to the point, but to the point. Not more than the point. Blue color intensity of the solution, or you can write electrolyte, decrease. Or you can write reduces. Roman 2. A simple cell is made using a copper metal plate and a zinc metal plate. Copper and zinc. Copper and zinc. Copper and zinc. Copper and zinc. What are they talking about now? Now what are they talking about? Electrolysis the electrochemical cell. Electrochemical cell. Electrochemical cell. Tell me what's the solution? What's the electrolyte? In electrochemical cell, all the three, only one electrolyte. Our first part. What's the disulfuric. Disulfuric H2SO4. They are talking about zinc and copper, right? Yeah, copper and zinc. Copper and zinc. Copper and zinc. This is zinc. This is copper. externally connected. Who is more reactive? Who is more reactive? Zinc is more reactive. Then zinc will undergo what? Zinc will undergo what? Oxidation. Zinc will undergo oxidation. If zinc undergoes oxidation, zinc is anode or cathode? What? Anode. Zinc is anode. It undergoes oxidation. Tell me the oxidation of zinc. Zinc solid converts to zinc solid convert to zinc plus 2 aqueous by liberating 2 electrons. It is jumping into the solution. Next, if this is anode, this becomes a cathode. Here electrons are released, it becomes negative terminal. This becomes positive terminal. Sorry? And I told you, all the electrochemical cell reduction is the same. Close the eyes and tell me thing. What's the reduction? No need to even use any logic. Only one reduction. All the electrochemical cell. Who undergoes reduction? H plus. 2H plus. 2H plus aqueous gains 2 electron forming H2 gas. Good. What are they asking? Which metal acts as the anode of the simple cell? Is that a question? Is a question that should be asked in O-level exam. What is the anode here? What's the anode? Zinc. Very good. Zinc is the anode. I'll write it there itself. Look at the questions coming in O-level paper. Essay question. Electrochemistry. For this only all were telling hard. Electrochemistry hard. B part. In which all the lessons are like that only. Whatever you tell hard. And it's electromagnetism, electromagnetic induction hard. Biological process in human body. I can't touch it. I'm worried about it. Everything is easy. The only thing is the way you look and way you understand the lesson. B part. In which type of ion does the concentration remain constant in the solution of the electrolyte when the simple cell operates? This one also no need to think a lot. Very simply think. Very simply from the base thinking. In which type of the ion does the concentration remain constant? Now think very simply. For the concentration to remain constant, that ion should not be used during the reaction. Agree to my point? Agree to my point? For the concentration to remain constant, that ion should not be used. It should not undergo oxidation, it should not undergo reduction, or it should not undergo any changes. In which type of ion does the concentration remain constant in the solution of the electrolyte when simple cell operates? Now think. Which ion is not undergoing any changes? First tell me the ions in this solution. Dilute sulfuric acid is there. From the acid, what are the ions we get? H plus, very good. What else? What's the negative ion there? Sulfate, SO4 minus 2. Good. It's in aqueous state. What else? From the water, H plus will come. No need to write again. And from the water, what's the negative ion? OH minus. Additionally, someone is jumping into the solution. Who is that? Who is jumping into the solution? Zinc plus 2. These are the ions. First think. What are the ions undergoing a change? See, zinc is jumping into the solution as zinc plus 2. Then zinc plus 2 ion concentration in the solution will slowly slowly increase. Again, see, zinc is jumping into the solution forming zinc plus 2. Then zinc plus 2 ion concentration in the solution will increase. Agree to my point? Agree to my point? You're taking some balls and throwing it to the water. One by one, you're throwing it to the water. Number of balls in the water will increase. Agree? You're taking zinc, converting into zinc plus 2, throwing it to the water, throwing into the solution. The zinc plus 2 concentration increase, no? So it is undergoing a change. Its concentration is changing. Come to H plus. My H plus is undergoing a reaction. H plus is converting into hydrogen gas. H plus is converting into hydrogen gas. Then it is undergoing a change or not undergoing a change? Undergoing a change. H plus is undergoing a change. Come to OH minus. OH minus comes from whom? From what compound OH minus is released? What? Water releases OH minus by complete ionization or incomplete ionization? Incomplete. Partial ionization. Water can't completely ionize. Water undergoes incomplete ionization. If it undergoes incomplete ionization, it will ionize and release OH minus. Again, it will form water. Again form OH minus. Again forms water. Again OH minus. Again form water. What can you tell about OH minus concentration? Constant or not changing? A constant or changing? Alright. Water is forming OH minus. Again forming water. Again OH minus. Again water. Now think about OH minus. Forming OH minus, forming water. 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 What is happening? Constant or changing? What is happening? Change. It is change. So OH minus is also changing. What is the only ion not undergoing any changes? Anarite sulfate. It comes due to complete ionization of acid. It comes due to complete ionization of acid. Sulfate. So if you have gone wrong, maybe only that question you would have gone wrong. Other than that, I'm pretty much sure those who attended the chem night, all the other questions you would have got correct. This is a little thinking part is there. Okay. All correct. So there a little thinking part is there. Zinc plus 2 will undergo change. H plus is undergoing a change. OH minus is forming back again, it's undergoing a change. Then only ion is SO4 minus 2. That's the answer. Okay. No need of diagrams. They are not asking in diagrams. That is 2021 O-level paper. Go to 2020 O-level paper now. Go to 2020 O-level paper. Huh. They are in two papers. Right. First, when they give a diagram, Lamai. In essay questions, when they give a diagram, first take some time to look at the diagram, analyze it. Then go to the question. Now, what most of the students do is, just in the mood of quickly doing the question, they forget to go through the diagram carefully. When you don't go through the diagram carefully, after you read every question, you have to come back to the diagram. After this question, you look at the diagram again. Again, you go to the next question, again look at the diagram. Again, next question. Actually, you are wasting time there. So best is maybe about 5 or 10 seconds you take. What are they talking about? Just analyze the diagram. What is happening? What type of cell is this? What type of cell is this? Just analyze a little bit. Huh. Now look at the diagram first. Cell U is there, cell W is there. This one. Zinc rod is there, copper rod is there. Dilute sulfuric acid is there. There is no battery. That means you are producing current. You are producing current. What cell is that? What cell is that? Electrochemical cell. Electrochemical cell. That's the electrochemical cell. Our first part. This is electrochemical cell. Look at this one. Aqueous copper sulfate is there. Carbon electrodes are there. What cell? What cell? Electrolytic cell. I have nothing to teach. Why? Previous paper had both those cells. Look. Look. Previous paper, copper sulfate aqueous. Here, copper sulfate aqueous. Harine. Previous paper, zinc and where? Copper. Here also, zinc and copper. Then y'all tell me, for a person who has done 2020 O-level pass paper and gone for 2021 paper, will he feel anything hard? Will he feel anything hard? And that's the beauty of doing past papers. Now I have nothing to teach. My job is made easy. Right. So cell U is electrochemical cell, cell W is electrolytic cell. Now we all know the oxidation, you all know reduction. We'll go to the question. Roman 1. In which cell above is chemical energy converted to electrical energy? Think. Where you do a chemical reaction, produce current. Where you do a chemical reaction and you produce current. Output should be producing current. And electrochemical cell. In electrochemical cell, see, you are doing a reaction in the solution. From the reaction, you are producing current. So you are doing a chemical reaction. From that, you are producing electric current. Here, it's the opposite. Electrolytic cell, it's the opposite. Here, you are giving current. Battery should be connected. Current is given. Cell is connected. You are giving current. Electricity is given. From there, you are doing a reaction. It's the opposite. You are giving current, doing a reaction. Here, you are doing a reaction, giving and getting current. So the question is asking, in which of the cell above is chemical energy converted to electric energy? Chemical to electric energy, cell U. Cell U. So Roman 1, cell U. Next, Roman 2. What is the name by which anode reaction occurring in the two cells are known as commonly? You all tell me, at anode, what reaction occurs? At anode, what reaction occurs? Oxidation. That is how anode is defined. Anode is the place where oxidation half reaction takes. So what is the name by which anode reaction occurring is known as oxidation? Properly write it, Lamai, oxidation reaction, or you can write oxidation half reaction. Next, Roman 3. Indicate the half reaction occurring at the anode of cell U by a chemical equation. Cell U, zinc and copper. Now tell me, now we are not going to analyze anything. Zinc and copper, who will undergo oxidation? And right. Tell me the oxidation of zinc. We'll write it again, it's a practice, no? Roman 3. Roman 3, question 14, Roman 3. Question 14, Roman 3. What's the oxidation of zinc? Zinc solid converts to zinc plus 2 aqueous, liberating how many electrons? 2 electrons. That is Roman 3. State the convection used to identify anode and cathode in cell W. What is the convection? What's the logic we use to identify anode and cathode? What is anode? Place where oxidation half reaction takes place. What is cathode? place where reduction of reaction take place. That is the logic we use. That's the convection we use. That's the answer. Place where oxidation reaction take place is anode. Place where reduction reaction take place is cathode. Wrote that? Wrote that? So anode is the place where oxidation, I'll write it simply, I'll elaborate and write. Oxidation reaction takes place. Cathode is the place where reduction half reaction takes place. Okay. What about writing positive and negative? I would tell don't write it. In O level, they will give marks. But what did I tell? You don't define anode and cathode based on positive or negative. No? How you define anode and cathode? Based on oxidation and reduction. So don't go to define it based on positive negative. It's not standard. In standard, what is anode? When I ask you what is anode, what is your answer? Place where oxidation of reaction takes place. What is cathode? Place where reduction of reaction takes place. So always stick to that definition. Don't define it in terms of positive negative. That's not a standard definition. Write it standard definition. Then examiner knows that you know chemistry. Only thing that you should show the examiner in essay paper is you should show that you know the science. Maybe you write lie, but that lie should adhere to science. You get the point? That's the art of doing paper. Right? So you show the examiner, I know science. I know the standard science. So it's okay to write positive, negative because they have emphasized on this thing. No? Yeah. State the convection used to identify anode cathode in cell W. So cell is defined. Cell is emphasized. Cell W means electrolytic cell. In electrolytic cell, your positive terminal becomes your cathode. Positive becomes your anode. Negative becomes your cathode. So that way you can define, but that's not the correct way. Anode is a place where oxidation takes place. Cathode is a place where reduction takes place. Use that standard science. Huh? So that is that. Roman 4. Roman 5. What change, A part, what change in color occurs in electrolytic solution when cell W operates? Hey, tell me. Now for the second time. Asking the same question. Tell me. Blue color intensity decreases. That one. Now I'm also lazy. Writing the same answers again and again. Roman 5, A part. Blue color intensity of solution decreases. You all right fully, eh? Blue color intensity of the solution decreases. B part. Explain the reason for it. And there you have something to think of. In theory class, I went very deep and taught it. When we were doing electrochemistry in theory classes, why the blue color intensity decreases. Now listen, eh? Why actually this blue color is decreasing? See, Lamai. Now see. Copper sulfate. What is the color of copper sulfate aqueous? What is the color of copper sulfate aqueous? Blue color. This is blue color. Why it is blue color? Who is giving the color there? Now see, Lamai. Copper sulfate. Copper sulfate consists of copper plus 2 ion, SO4 minus 2 ions. These are the 2 ions present in copper sulfate. This sulfate ion is colorless. Sulfate is colorless. It doesn't have any color. Now, if it has any color, then sulfuric acid also will be colored. No? Just imagine if sulfate has any color, then sulfuric acid also will get a color. So remember, sulfate doesn't have any color. Sulfate doesn't have any color. Then who has that blue color? Which ion has the blue color there? Copper plus 2. Copper plus 2 is only blue color. Copper plus 2 is blue color. Sulfate is colorless. Sulfate colorless, copper plus 2 blue color, both together. Finally, copper sulfate what color? Blue color. That is how copper sulfate gets color. Copper sulfate is made of copper plus 2 and SO4 minus 2. SO4 minus 2 is colorless. Copper plus 2 is blue. As copper plus 2 is blue, only copper sulfate is blue color. Now see, during the cell process, we wrote the reaction. During the cell process, electrolysis of aqueous copper sulfate. What is happening to the copper plus 2 ions? Now this is only blue color. What is happening to the copper plus 2 ion? It is converting to copper. Copper plus 2 is converting to copper. That means copper plus 2 ions in the solution is decreasing. Agree? Copper plus 2 is converting into copper. Then copper plus 2 concentration is decreasing. Copper plus 2 is only blue color. As copper plus 2 concentration is decreasing, what happens to blue color? Blue color also decreases. That's the real reason. That's the real reason. So remember, in copper sulfate, copper plus 2 is blue color. During the cell process, copper plus 2 forms copper. Then copper plus 2 concentration decreases. Copper plus 2 is blue color also decreases. So how do you write it? Write the reason there. Now you put it into a sentence and I say write down. Copper plus 2 ions are blue color. During the cell process, copper plus 2 concentration is decreasing. Therefore, blue color intensity of the solution is also decreasing. Shall I tell it? Those who wrote any different answers, probably write it and keep. Maybe in the tute itself, write it and keep. Under copper sulfate electrolysis, in the tute itself, if you have a space there, write it and keep. Right there. During the cell process, during the cell process, copper plus 2 ion concentration, copper plus 2 ion concentration copper plus 2 ion concentration decreases. Therefore, blue color intensity, of the solution also decreases. Therefore, blue color intensity of the solution also decreases. Blue color intensity of the solution also decreases. Again, I'll repeat. See whether you wrote properly. During the cell process, copper plus 2 ion concentration decreases. Therefore, Blue color intensity of the solution also decreases. Roman 6. Which electrode is dissolved when the above cell operates? Tell me. First tell me. Will carbon electrode ever dissolve? Will carbon electrode ever dissolve? Never, eh? Carbon electrode will never dissolve. It's an inert one. It won't react. That is why you are using carbon electrode. So carbon electrode never dissolves. Electrolytic cell, the electrode never dissolves. Only in electrochemical cell, one electrode is going to dissolve. What is that? More reactive metal or less reactive metal? More reactive. Anode will dissolve. Who is the anode here? Zinc. Zinc. So your answer is only zinc. Nothing else will dissolve. Only zinc. Okay. Okay. And some of you were asking me, so what about the redox reaction? Redox, just go through those sections and just keep the redox. Usually in the exam, they won't ask you to write the redox, the complete reaction. The complete reaction, the redox, most of the time they won't ask. Now you all did all these questions. No? Was there any place where they asked you to write the redox? These are past paper questions. No? Was there any place where you came across a place where to write redox? No. Mostly what they ask you to write is anode reaction, cathode reaction. Unless and otherwise, the papers really need to be made strict and hard. If it is really needed to be made hard, right, trying to make the students fail, they will put that section. They won't do it. They won't do it, right? Because they wanted to keep the pass rate, right? That pass rate, there is a level. When setting the paper, there is a standard. That standard is not very high. That standard is not very low. Everyone should get a pass mark. There is a standard there. So when they are setting the paper, they won't make it that hard. So most of the time, they don't test the redox. 99% they won't test the redox. That's why even in the night class, I didn't touch the redox part. If you touch the redox part, full night we have to do only the electrochemistry section. But just in your textbook, go through the redox, just how it is written. Maybe in MCQ question, they might ask you. They might give you two anodic cathodic reaction and ask you which one is correct redox. They might ask. So just go through that key. They won't ask deeply about it. Redox is the complete reaction. Question 13. However, in our theory class, we have written all the redox for all the electrochemical cells. Or electrochemical cell, electrolytic cell, or for all, for rusting, for everything, redox we have written. The relativity we have written. All the redox we have written. And I have taught you all the logic calls. No need to memorize that. Hurry. 13th question. Figure 1 and 2 below illustrates two electrolytic cells arranged to electrolyze fused sodium chloride. Read this. Now your brain should go to that point. It should go to the directory. Fused sodium chloride. Ding 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 ding. Will revise. Fused sodium chloride. Fused sodium chloride. Dingala. Brain should work on fused sodium chloride. NaCl liquid. Some people, those have gone through my summary note properly. Now you can locate it also in electrolysis. Second set. Electrolysis first row. Can remember? Electrolysis first row. Those have gone through that summary note, they can locate it. Electrolysis first row. Dingala will revise. Usually we don't do it in a beaker. I told you. Reason also I told you. Electrolysis. Two carbon rods are added. Positive, negative. You have your sodium chloride liquid there. Sodium chloride liquid now what are the ions lamai? Na plus and Cl minus. Can you remember only at this place we write the ions in liquid state? Can you remember those points? If you didn't sleep that day, if you were not sleepy that day, Only at this point we don't write aqueous. We write it in liquid state. And can remember logic? No logic. Negative undergoes oxidation. That's the logic. Keep that in mind. Electrode connected to the positive terminal, positive. Electrode connected to the negative terminal, negative. No logic. Negative undergoes oxidation. Negative. Negative go to the positive terminal, undergoes oxidation. Tell me the oxidation of chloride ion. Tell me the oxidation of chloride ion. How many chloride? How many chloride? 2Cl minus. What's the state? What's the state, Puta? Liquid state. Converts to form Cl2 gas, liberating 2 electrons. Reduction. Positive undergoes reduction. Na plus is positive. It goes to the negative electrode, undergoes reduction. Na plus. What's the state? Liquid. Gains 1 electron, forming Na. It is also in liquid state. That is electrolysis of fused sodium chloride and aqueous solution of sodium chloride. Aqueous solution of sodium chloride. You revise that also. NaCl aqueous. Now things should flow in your mind. In your brain, it should flow and come. That's what I told you. With Chem Night, we are studying, we are revising, we are putting into the mind, everything is done. Again, you can't keep a separate time to study. That night it's done. So now you touch the questions. Sodium chloride aqueous. Sodium chloride aqueous. Electrodes are there. Positive, negative. Connected to the positive terminal, positive. Electrode connected to the negative terminal, negative. Tell me the positive ions in the negative ions. Na, NaCl, Na plus ion, Cl minus ion. Aqueous state. From aqueous state, water will undergo ionization. H plus ion, OH minus ion. Use the logic. No logic. Negative undergoes oxidation. Cl minus, OH minus. Who will undergo oxidation? First page. The point before the last. First page, the point before the last. Cl minus, OH minus will undergo oxidation. OH minus will undergo oxidation. Oxidation to Cl minus. Now what's the state? Aqueous state. Converts to form Cl2 gas plus 2 electrons. I'm trying to bring everything to your brain again. Now all these things are not needed to answer that question. But this is for you to check whether things are there in your brain. That night, whether you attended properly, whether things are there in the brain. From the other side. First, negative ions will go to the positive terminal. So both of them will go. Out of them, Cl minus undergo oxidation. Positive ions go to the negative terminal. Out of them, one will undergo reduction. Going to undergo reduction. Who is located lower in the activity? See? Lower. H plus. So H plus aqueous will gain 2 electron to form H2 gas. So from there you can tell this thing. H plus is also gone. Finally, 2 people are remaining. Na plus and OH minus. Both together will form what? NaOH. Acid the base. Base. Right. Now go to the question. An aqueous solution of sodium chloride respectively using carbon electrode. This is fused sodium chloride. This is aqueous sodium chloride. Unknown. Ions are not given. But what is given? I hope letters are clear to you. Q, R. This side aqueous sodium chloride. QR. Additionally, you have VW. We'll first find out which is Q, which is R. Can you see Q and R are common to both the cells? Can you say QR are both common to both the cells? If it is common, QR should be what? What is common to both? Na plus and Cl minus. Then QR should be Na plus Cl minus. One is Na plus, one is Cl minus. How to find which is Na plus, which is Cl minus? Which is Na plus, which is Cl minus? How to find? Onnalamai, Q is going to the positive terminal. If it is going to the positive terminal, can it be Na plus? Can it be Na plus? No. Negative won't go to, sorry, positive won't go to negative, positive. Q is going to the positive terminal, then Q should have negative charge. Negative charge is Cl minus. Onna ehenang. Q is going to be Cl minus. If Q is Cl minus, guaranteed R is what? Na plus. From there, you can find V and W as well. V and W as well. V and W comes from what? H plus NOH minus. Out of that, which is going to be H plus? Which is going to be H plus. H plus should go to the negative terminal. H plus should go to the negative terminal. H plus should go to the negative terminal. W. W goes to the negative terminal. Then W is H plus. If W is H plus, guaranteed V is what? OH minus. Guaranteed V is OH minus. Ions, there's a spelling mistake here, printing mistake here. Not, this should be R. This should be R. Hope you all would have correct. RQVW move in the directions indicated by the arrows during electrolysis of these. The ion Q and R are common to both the cells. Roman 1. Write the chemical symbol of QRW. Q is Cl minus, R is Na plus, WH plus. Got it? Got it? What is it? Yes. Roman 2. A part. Write the half reaction occurring at the cathode of the cell in figure 1. Figure 1 is electrolysis of fused sodium chloride. At the cathode, reduction will take place. At cathode, reduction will take place. What is the reduction at the cathode? Onna puthe we have written. That's a reduction. That's a reduction. Write it separately and keep. Roman 2a. At the cathode, reduction will take place. Na plus liquid will gain one electron, forming Na liquid. Next one. Why is that reaction known as reduction reaction? Tell me, Lamai, what is reduction reaction? What is reduction reaction? Gaining electron. Or even you can tell reduction in the oxidation number. Can remember? Two definitions I gave. Gaining electron is reduction, or you can tell reduction in the oxidation number. Anything you can tell. So maybe you can tell gaining electron. Gaining electron. But properly elaborate it and write. During the reaction, electrons are gained, therefore it's called reduction reaction. Roman 3. Write the half reaction occurring at anode of cell in figure 2. Figure 2 is aqueous sodium chloride. Aqueous sodium chloride anode oxidation will take place. Oxidation, as the oxidation on this one. Chloride oxidation. Chloride oxidation. Chloride oxidation. 2Cl minus aqueous converts to form Cl2 gas, liberating 2 electrons. Roman 4. What metallic electrode can be used instead of carbon electrode? Instead of carbon, what else you can use? Platinum. It's a metal, metallic electrode. So that is platinum. That is platinum. Roman 5. In the cell indicated by which figure does the reaction taking place in down cell during the extraction of sodium happens? And that is down cell process is happening, figure 1 or figure 2. Molten sodium chloride. Figure 1. I told you, you can't do this in beaker, you do it in down cell. So that is figure 1. That is figure 1. Roman 6. Roman 6a. Few drops of phenolphthalein were added to the solution contained in the cell in figure 2 when electrolysis happens. State the observation that can be made at the moment. You all tell me. Phenomena teacher wears what color sari? Pink color sari. Phenolphthalein gives pink color in presence of what? Phenolphthalein gives pink color in presence of what? Bioteacher. Bioteacher. In presence of base. Now they are telling when the second cell, figure 2, is functioning, they are putting some phenolphthalein. Phenolphthalein is put inside. It is forming sodium hydroxide. Sodium hydroxide is a base. Then it will give what color? This will give what color? Pink color. What's your observation? Phenolphthalein turns pink. Phenolphthalein turns, I'll write it in short, pink. Phenolphthalein turns pink. Explain the reason for the observation you stated. Why it is turning pink, Lamin? Don't just write due to base. Properly elaborate your answer and write. Why it is turning pink? Due to presence of what? Sodium hydroxide. Due to the formation of sodium hydroxide, which is a base. Or even you can tell due to the formation of hydroxide ion. Due to the presence of hydroxide ion. So anything you can write. I'll write due to the formation of sodium hydroxide. That is question number what? That is question number 6. Sorry. Not 4. That's question number 6. 6A and B. Clear? Got everything perfect. All correct. Yeah. That is 13th question. What are the questions I told we'll be doing? Until 12 or until 11? I didn't tell 11. What? We'll do until 12. Hurry, I'm wait. 12th question. In the following figures, two cells are given as A and B. Zinc iron electrode dilutes sulfuric acid. What cell? What cell? Now your turn. You all are answering me everything now. Electrochemical cell. Electrochemical cell. I'll write it as easy. Electrochemical cell. Carbon electrode, fuse sodium chloride. You are same thing we did before, no? That's the same thing. What is this? Electrolysis. Electrolytic cell. This is a electrolytic cell. Electrolysis is happening. Look at the questions they are asking for a person who has done 2017 O-level paper and gone for 2019. Nothing big. Eh? There's no big difference. Hurry. We'll do the questions. Roman 1. From the above two cells A and B, which is the electrolytic cell? What's the electrolytic cell? Where electrolysis is taking place? B. Electrolytic cell is B. Electrochemical cell is A. I will tell one more point. Actually, we don't use that name now. In old syllabus, we used to use it. Electrochemical cell, you can even call it galvanic cell. But in reality, galvanic cell and electrochemical cell has a bit of a difference. But in old syllabus, right, they use the term galvanic cell. Sometimes if you look at very old question, 1980s, you can come across that name. Just go through this question. You will come across those names as well. Galvanic cell. I can't remember what are the places. However, even that name is then and there used. Then and there it's used. Galvanic cell, electrochemical cell. The other one is electrolytic cell. Okay. So here they are asking electrolytic cell, answer B. Roman 2, write one observation that could be obtained when the cell A operates. A operates. Lamai, tell me. All the electrochemical cells, only 3 observations, no? Can remember the first table? Only 3 observations. Anode dissolves as bubbles are liberated at cathode. What else you can tell? Beaker becomes hot. Did I give that in the tube? Beaker becomes hot pot? No, write it also and keep in the tube. Beaker becomes hot. In the tube. Only anode cathode I give. Need. Write it and keep. Beaker becomes hot as well. So those are the 3 observations. They are asking one observation. You can write zinc rod dissolves. Or you can write gas bubbles are liberated at iron electrode. I'll write zinc rod dissolves. Zinc dissolves. Roman 3a. Roman 3a. Write the cathodic reaction that take place in cell B. Onnalamai cell B. Cathodic reaction is reduction. Fuse sodium chloride. Now logically do. Fuse sodium chloride. Think. Now you should process in your mind. See whether you can do this using the mind. Fuse sodium chloride. Think of our tiote. Go to fuse sodium chloride in your mind. Navigate. Fuse sodium chloride. Na plus signs are there. Cl minus signs are there. Use the logic in your mind. No logic. Negative undergoes oxidation. Then who will undergo reduction? Positive. Negative undergoes oxidation. Then who will undergo reduction? Positive. Place where reduction takes place is cathode. They are asking cathodic reaction. That means positive reaction. Only one positive is there. What is that positive? Na plus. On that way you navigate in your mind now. Now things are there in the mind. Now you do the mind game. So your answer is Na plus cathodic reaction. You should write the reaction. 12th question, Roman 3A. On 12th question, Roman Roman 3A. So Na plus. Tell me the state. The state, liquid state. Use sodium chloride, gains the electron, forms Na liquid. B part. What is the name commonly given to the electrode where oxidation reaction take place in both the cells? On that same question we did somewhere. Naming part. Tell me where oxidation take place. What's the common name? Don't get wrong. Don't get wrong. Even if you are in the lowest marks in the school, this question you should be able to answer me. Anode. So the answer is anode. Roman 4. What is the reason for not using cell B in the production of sodium metal industrially? Why you can't use this cell? Now, one reason you can tell, because you have to heat it a lot. Beaker doesn't support it. But are you sure this is a beaker? Have they named it as a beaker? Is the name beaker given there? Is the name beaker given? So don't go for that option. If something is not given, don't go for that option. If you don't have any option, then go for that option. Here, beaker, they are not named it. Maybe it's very heat resistive metallic container. Possible, no? Maybe it's a high heat resistive metallic container. They are not told it. Maybe it's a beaker. So don't use that word. Beaker might melt or beaker might not withstand high heat. You can get marks, but it's not highly specific. Go for the next option. What's the other option? What's the other option? Why you can't do it in this setup? What is missing in this setup? What is missing in this setup? Onnalamai. In the middle, perforated iron mesh is missing. No? What's the function of this perforated mesh? The diaphragm. Can remember? Under industrial application of sodium, I have given the last point there. What's the use of this perforated mesh there? Diaphragm. It prevents sodium and chlorine from joining together and again forming sodium chloride. Sodium is there, chlorine is there. It can join and sometimes form sodium chloride. So this perforated diaphragm only prevents sodium and chlorine from joining and again forming sodium chloride. So here it is not there. What will happen? The formed sodium and formed chlorine can join again to form sodium chloride. Formed sodium and formed chlorine can join to form sodium chloride. That's the answer. Write the answer there. Those who didn't write the answer. The formed sodium, sodium, the formed sodium and chlorine Cl2, and chlorine Cl2, chlorine, the formed sodium and chlorine can again join to produce sodium chloride. To produce sodium chloride. to produce sodium chloride. Huh. Tomorrow, Friday, no? Tomorrow, we'll do like this. In this, I wanted to discuss the I wanted to discuss the 11th question. That's a good question. I couldn't put it in the group. So finish off the 11th question. Finish off the 11th question and all the MCQs. All the MCQs and 11th question. So tomorrow we will discuss all the MCQs and the 11th question. So with that, electrochemistry should be okay from your end. Already okay? Can go in the final exam? Yes. Now that confidence is there. Perfect. Really great to hear. So touch that question for sure. Your final exam is a place where you can touch. So that is for tomorrow. Tomorrow, then all the MCQ finish off and finish off the 11th essay question. Right? With that electrochemistry done and dusted, I think no need to touch it. No need to touch it. Maybe the day before the exam, just go through the short note I gave. That's enough. So one lesson relief from there. Right? As well as the other lessons also we discuss mixtures also. We have right. මේවා ටික දැන් ඉවර කරන්න. හරි. හරි එන්න. Enough for today. Enough for today. Finish off the remaining. Finish off the MCQs and the 11th question. Tomorrow night, I'll discuss and I'll finish off electrochemistry. So from tomorrow, tata bye bye to electrochemistry until the day before the exam. My idea. Still, if you have any parts problematic, by tomorrow we are finishing off. You are finishing, me finishing, everyone finishing. By tomorrow we are finishing off. The doubtful section, go through reactions again, write one time, go through the complete note with electrochemistry done. Right? Hurry, need. Okay. Okay then. Enough for today. Keep working hard. I'll meet you all again tomorrow night. Until then, bye.